Hello, good morning students. Today we are going to discuss atoms. So the first concept is distance of closest approach. What is the meaning of distance of closest approach? If I am going to consider first point here, it is between two like charges. Second condition, one of the charge deflected by 180 degrees. These are the two conditions required. Here I am going to consider a nucleus. It is a nucleus of any atom and this is the alpha particle. Now the alpha particle is moving with kinetic energy K. With kinetic energy K towards the nucleus. Both are like particle, positive and positive. Because of there is a repulsion force, kinetic energy goes on decreases. So velocity goes on decreases because of repulsion force between these two. So while it is moving, kinetic energy goes on decreases. At a particular point, what happens? Kinetic energy of the alpha particle becomes zero. Kinetic energy of the alpha particle becomes zero. When at what point kinetic energy of the alpha particle becomes zero? From that point to nuclear distance, we call it as distance of closest approach. So now, where the kinetic energy of the alpha particle zero, from that point to nucleus center, distance between these two we call it as distance of closest approach, and we are going to represent it with a symbol R, where R is equal to distance of closest approach. Now closest approach, distance of closest approach, you are going to understand. Now how to calculate the distance of closest approach, you will see. What is the closest approach means? Wherever the alpha particle have the kinetic energy while moving towards the alpha particle because of repulsion force. Why? Because both are like charges. Because of like charges, there is a repulsion force between them. So kinetic energy goes on decreases. At a particular point, what happens? Alpha particle kinetic energy becomes to zero. At what point kinetic energy of the alpha particle is zero? From that point to center of the nucleus, the distance is called distance of closest approach. At distance of closest approach, what will happen? Here kinetic energy completely becomes zero, and because of repulsion force between these two, it will be returned back or replaced in the same path. So that's why what happened? Initial direction this one, and after kinetic energy becomes zero, its path changes to back, reverse. Then what is the deflected angle? 180 degrees. That's why I said one of the charge deflected by 180 degrees. So this point to the center of the nucleus, the distance between these two, where the kinetic energy is zero, that point to center, the distance between these 2 points generally we call it as distance of closest approach. Now how to calculate the distance of closest approach? At this point, what will happen? Kinetic energy goes on decreases. The decreased kinetic energy converted as a electrostatic potential energy. The decreased kinetic energy converted as a potential energy. That potential energy we call it as electrostatic potential energy. Here what happens? Whenever the kinetic energy becomes zero, the total kinetic energy converted as a electrostatic potential energy. At this point, alpha particle, here nucleus, what is the electrostatic potential energy between these two at this place? So I'm going to calculate potential energy between these two. So 1 by 4 pi epsilon naught, 1 upon 4 pi epsilon naught, product of charges, alpha particle charge. So alpha particle charge we know that 2e, and the nucleus charge we know that Ze. That is depending upon the atomic number of the nucleus. Suppose if I am going to consider gold nucleus means gold atomic number 79. Then what is the charge of the gold nucleus? 79e. That is the meaning of Ze. So what is the charge of the nucleus? Ze. Then how to calculate the potential energy between these two charged particles? Nucleus is positive charge, alpha particle is positive charge. So what is the potential energy? 1 by 4 pi epsilon naught, product of charges. What is the product of charges? Alpha particle charge into nucleus charge, Ze by distance between these 2 points. That is the potential energy formula. Already we know that potential energy formula is equal to 1 by 4 pi epsilon naught product of charges by distance from the electrostatics. The same formula used here. 1 by 4 pi epsilon naught 2E ZE by R. This is the potential energy. Here what happened at this point? Total kinetic energy becomes 0. The total kinetic energy converted as a potential energy. At this point, at a distance of closest approach, at this point what happened? Total kinetic energy converted as a potential energy. Generally, what is the kinetic energy? Kinetic energy is equal to half mv square. We know that. If you want to equate these two, that is half mv square is equal to 1 by 4 pi epsilon naught 2e times ZE by R. By using this formula, anyone we can calculate the required one. So if suppose you require closest approach distance means R can you calculate. Then they will give all the values. Sometimes they will give energy of the charged particle. At the time don't use half mv square, directly use the K, and which is equal to what? Potential energy. Then K is equal to what is the potential energy? 1 by 4 pi epsilon naught product of charges, charged particle of alpha particle and the nucleus by closest approach distance. So from here what is R? R is equal to 2E into ZE by 4 pi epsilon naught into K. K is the kinetic energy of the alpha particle. This is the distance of the closest approach formula. My dear student, this is explained just for understanding only. So finally you need to remember this formula. R is equal to 2E into ZE by 4 pi epsilon naught K. This is only you need to remember finally. Here, note down. Here whatever we are going to discuss in this, finally what we need to remember? Finally we need to remember simply kinetic energy is equal to 1 by 4 pi epsilon naught into product of charges. Charged particle, if it is alpha particle means 2E. ZE, nucleus charge by closest approach distance. If you require closest approach means 1 by 4 pi epsilon naught 2E times ZE by kinetic energy transposed to right side. So this is the required formula we need to remember for distance of closest approach. By using this formula, one can calculate closest approach distance. Suppose he is given one problem in this manner. One charged particle have energy 2.56 MeV, million electron volts. That is the one charged particle has the energy 2.56 MeV. That means the energy of the particle means that is definitely kinetic energy only. He not mentioned the energy name. He is given energy of the particle means we need to consider that is the kinetic energy of the particle. Okay, and we need to calculate the nucleus is gold nucleus. Nucleus is gold nucleus. That means this charged particle moving towards the gold nucleus. Then what is the ZE? Gold nucleus means Z means 79 for the gold. He will give in the bracket what is the atomic number for Z. So Z is the gold nucleus 79, and what is the E? 1.6 into 10 to the power of minus 19 coulombs. This is the charge of the gold nucleus. Then how to calculate the distance of closest approach? R is equal to 1 by 4 pi epsilon naught means 9 into 10 power 9 into 2 times E. What is the meaning of that? 2 into E is 1.6. Here what happened? E into E, E square. E into E, E square. That means 2 into Z into E square. 2 into Z into E square. So 2 into Z. What is Z? 79 into, if I am going to write ZE, 79 is the Z, 79 is the Z, and E into E, E square. E square means 1.6 into 10 to the power of minus 19 whole square upon K. What is K? Kinetic energy 2.56 MeV. 1 million electron volt means converted into joules. First million means 10 power 6 electron volts. 1 electron volts means 1.6 into 10 to the power of minus 19 joules. So million electron volts. How to convert it into SI unit? Million means 10 power 6. 10 power 6 electron volts. And electron volt is also not the SI unit. 1 electron volt means 1.6 into 10 to the power of minus 19 joules. So finally 1 MeV means how much? 1 MeV means 10 power 6 into 1.6 into 10 to the power of minus 19 joules. Now simplify this. You are going to get the distance of closest approach. That's all. This is the way we need to solve the problem. Note down, students.